I think the alternate segment theorem is the most feared theorem in all of circle geometry. Welcome to the only guide you will ever need to conquer the alternate segment theorem. No more guessing which angle equals which, because I will show you a simple visual trick to see the equal angles instantly and solve any WAEC or JAMB problem with confidence. Welcome to Post Scholars channel. I hope you are doing great. So the title of this video is Angle in Alternate Segments, right? Now let's explain this theorem before we dive into this question which we are going to solve together. Now what does angle in alternate segments theorem says? It simply says if you have a circle, right, and you also have a tangent. By now you should know what a tangent is. A tangent is any line that touches a circle at one point, right? Now this is the circle, this is the tangent, and this is the point of what? Tangency. Now if you have a shape like this inside the circle, let me draw it like a very good. Now alternate segment theorem is saying this angle, watch closely, this angle, right, is equal to this angle, right? Now the reason why I say is the most feared theorem in circle geometry is because of the fact that how do you 100% identify the two angles that will be equal? Now here's the trick to identify it. First of all, the first angle you will consider must be between a chord, you see it, and a tangent. That's the first angle. A chord and a tangent, right? While the other angle you'll be interested in will be the angle that the chord subtend. Look at this chord. Good. Where the angle is subtend? You see it? This is the angle the chord subtend. Definitely this angle is equal to this angle. Now let's go the other way around, right? The other way around. The other way around, the theorem is saying that this angle, right, is equal to this angle. Now let's apply what I just said. How do you know? First of all, there must be a chord, right, and a tangent. You see, this angle is in between a chord and a tangent. Then the other angle we'll be interested in is the angle this chord subtend at the other side of the circle, right, which is the alternate segment. You can see the angle it subtend. So this angle and this angle are equal. So that's the trick to always identify alternate segment theorem in any geometric question. Now let's solve this problem. This question says in the diagram, PT is a tangent to a circle. PT is a tangent to a circle ABCT. ABCT, all right? BA is equal to BT. Let's check it. BA, you see it is equal to BT. You can see the marks, right? The sign that they are both equal. And ATP equals 82 degree. ATP equals 82 degree. Calculate BCT. Calculate BCT. So this is the angle that we are interested in, right? Let's solve the question. Great. Now the mission is to find this angle. Angle what? Angle BCT. By now you should have known the principle of solving unknown in any diagram. You work with what you know. So what do we know? We know this angle to be given as what? 82 degree. Using alternate segment theorem, if this angle is 82 degree, this angle will also be what? 82 degree. And what's the name of this angle? ABT. So write it. Angle ABT is equal to what? 82 degree. And what's the reason? Angle in alternate segments, right? So let's label it 82 degree, right? Remember, the mission is to find this angle. Now if you look at this triangle, we're told that this side and this side are equal. So we don't have issue. This is an isosceles triangle. And what's one property of isosceles triangle? Since this side and this side are equal, it simply means this angle and this angle will also be equal. But then we don't know it, so we'll label with what? X. So if this angle is X, this angle is also going to be what? X. Now we sum everything and equate it to 180 degree. Doing so, we have x plus 82 equals 180 degree. X plus x gives 2x plus 82 equals 180 degree. We subtract 82 from both sides, then we have 2x is equal to 180 minus 82. 2x is equal to 98. Dividing both sides by 2, we have 2 cancels to x is equal to 49 degree. But we are not done, right? We are not done. We have only gotten the value of what? X. The question asks us to find BCT, this angle. Since this angle, right, x has been gotten to be what? 49 degree. Let me replace it with 49. Let's do that. 49 degree and also 49 degree. Good. Now, remember one theorem that says opposite angle in a cycle. You can see it. That's why I do tell my students, if you want to solve any circle geometry problem, you must know all the theorems. Very important. So if you are just watching this video for the first time, please go back to my video titled Circle Geometry Theorem. Watch everything, you understand, so that you have an idea on how all the theorems work. So one theorem says angle in opposite angle in a cyclic quadrilateral are supplementary. Add this angle and this angle, it must sum up to 180 degree, right? So this angle is angle BCT. So write it. BCT, angle BCT plus 49 equal 180 degree. What's the reason? Supplementary angle, right? Now next, subtract 49 from both sides, then you have BCT is equal to 180 minus 49. Finally, BCT is equal to 180 minus 49 gives 131 degree. And that's our final answer. You see, BCT is 131 degree. BCT, this part of the angle, is 131 degree, right? And the question, we have answered the question, which says find what? BCT, right? If you actually enjoyed this video, do well to subscribe to my channel, like this video, and share it among your colleagues and classmates. Thanks for watching. God bless you, and bye.